Hello, so this is for project number 7. I already import the data. So next I'm going to create the path model. Okay, then input A, A, then I, next is R, and S. Rename A, I, and S. Next I'm going to connect the variable, connect A to R, I to R, and R to S. So it changes from red to blue color once it interlinks to one another. And the arrows are representing the directional relationship between all the variables. Next, we're going to calculate PLS algorithm. Start calculation. We'll check outer loadings. So in these outer loadings, the value must be above 0.7. If it is below 0.7, the data must be deleted. And as you can see, there is one value that is below 0.7. It's this one, the I3. However, before we delete this, we have to check the average variance extracted. We'll check the AVE. So this is the AVE. So the AVE must be above 0.5 from the confidence interval 95%. And as we can see from this table, all the AVE are higher than 0.5. Therefore, we do not need to delete this data or this indicator, the I3. We don't have to delete it. And the composite reliability and the Cronbach alpha is pretty similar, but most likely we use and we check only the composite reliability because it is more precise than the Cronbach alpha. And in this composite reliability, the higher value indicates a higher level of reliability. So if it is between 0.6 and 0.7, it considered to be acceptable. From 0.7 to 0.9, satisfactory or good. Above 0.9, it considered to be problematic. If the reliability value is above 0.95, it means that there is a possibility of undesirable response between variable. If we check our variable, we can see that everything has a good level of reliability because it is between 0.7 and 0.9. So it's good. Next, we'll check our R-square. So this is our R-square. From the R variable, it's 0.575. I will just take a look at the R-square from the diagram. So here, the R is 0.575 or 5.75%, and the S variable is 0.541 or 5.41%. It means that from all the variable, there is a 5.41% that affects the S variable. Next, we'll check the F square. So in the F square, if it is below 0.02, it means that there is no significant effect. If it is equals 0.02, it has small effect. Equals to 0.15 has medium effect. Equals to 0.35, it has large effect. If we take a look at our data, between the data variable A and R, it indicates a large effect. It's considered to have a large effect because it is close to 0.35. So this one has large effect. This one has medium effect, and between variable R and S, it has a really high or large effect. Next, we'll check the collinearity statistic. So in this collinearity statistics, all the value must be between 1 to 3, both in the inner and the outer VIF. So if as you can see, all the data are between 1 to 3. If it is higher than, for example, if we get the result of 5 point something, if it is higher than 5, it indicates a critical collinearity issue among the indicators. So in this table, everything is between 1 to 3, which means that it has good relation. Next, discriminant validity. In this discriminant validity, everything should be higher than, it should be lower than 0.9 or 0.85. And as we can see, all data sets are below 0.9. And next, we're going to calculate bootstrapping. Calculate bootstrapping. We'll change it to 3000. Start. Okay. The p-value must be below 0.05. If it is higher than 0.05, it means that it has no significant effect. And as you can see, from A to R, I to R, and R to S, everything is below 0.05. It means that all the variables has significant effect. And then we also only focus on the one that is linked to the variable as our dependent variable. In this case, because all the value are 0.0, which includes the R variable to S variable, which is also 0.0, it means that it has significant effect. Next, outer loadings. So all the value here has a significant effect. And the path coefficient, this is the histogram, and it's pretty much the same. Okay, next, we're going to calculate bind folding. Click bind folding. Start. So this is the Q-square. The Q-square value for variable R and variable S are all below are all above, above 0, indicating that they are meaningful and are defined to have a medium predictive accuracy of the PLS path model. Okay, that's all for bind folding. Next, the PLS predict. This is the Q-square predict. This Q-square predict values for the target variables, the S variable, are shown to be meaningful, have indicate medium, it has medium predictive accuracy for the PLS path model as 0.25 less than Q square less than 0.5. Next, the mapping. As our dependent variable, this is mapping. Okay. So from the graph, it is shown that variable A and variable I, this is A and I, the red and the blue dot, is above 50, above the value of 50 with respect to variable S. But but these two do not impact performance as they fall below 0.35 here. 0.35. The A and I are below 0.35. Therefore, they do not impact the performance. And the variable R is shown to be significant and has an impact on performance as it is above 50, above the value of 50 with respect to variable s, and is above 0.35 with respect to total effects. So that's all for today's assignment. Thank you.